Welcome to Healthy Living, Healthy Planet Radio, sponsored by EarthX, the world's largest environmental experience, and also sponsored by Natural Awakenings magazine. Live your healthiest life on a healthier planet. Now here's your host, Bernice Butler.
Welcome to Healthy Living, Healthy Planet Radio today. We are now in our third season, and we are still just as excited as we were to begin to continue to help you explore and understand the unbreakable relationship between your health and the health of the planet. Here we look at the hottest topics related to our environment and its sustainability and how they affect your health and wellness. Here, issues like climate change, plastic pollution, extreme weather events, and others will meet up with everyday impacts like allergies and asthma, digestive issues and gut health, cancers, lung and heart issues, and more. So listen in today as we interview experts for today's show, the first in our November series on extreme weather events. And today we're going to be talking about extreme heat. Recently, I read an article titled 5 Ways Climate Change Will Affect You. And one of those ways was aptly called wild weather, a very descriptively appropriate term. I think I like the term wild weather because that's exactly how me and most of us feel when we're experiencing it and its aftermath. However, scientists, researchers, weather, and climate professionals refer to it as extreme weather or extreme weather events. But I'm going with wild weather. Catastrophes are on the rise. Meteorological records show a definitive rise in weather-related disasters since 1980. And climate change affects some weather, but experts caution us against blaming it for every extreme weather event. In the early 2000s, or thereabouts, a new field of climate science research emerged that began to explore the human fingerprint on extreme weather, such as floods, heat waves, droughts, and storms. And it was known or called extreme event attribution, i.e., are we attributing these extreme weather events to climate issues? And, of course, the field has gained momentum not only in the science world, but also in the media and in these public imaginations. And their studies have the power to link what seems to be the abstract concept of climate change with personable and very tangible experiences of weather and wild weather. Scientists have published more than about 350 peer-reviewed studies looking at weather extremes around the world, all the way from heat waves in Sweden and droughts in South Africa to flooding in Bangladesh and hurricanes in the Caribbean. And the result is mounting evidence, almost conclusively, but not quite, but certainly mounting, that human activity is raising the risk of some types of extreme weather, especially those linked to heat. One analysis of extreme weather attribution studies that looked at these studies published to date reveals that 70% of approximately 405 extreme weather events and trends included in the study were found to be made more likely or more severe by human-caused climate change, and that 9% of events or trends were made less likely or less severe by climate change, which of course means that 79% of all the events experienced had some human impact. And then the remaining 21% of events and trends showed no discernible human influence or they were inconclusive. And of the 122 attribution studies that they looked at extreme heat around the world, and they found that 92% found that climate change made the extreme heat event or trend more likely or more severe. And for the 81 studies looking at rainfall or flooding, which we're going to talk about later on in other episodes this month, 58% of those found human activity had made the event more likely or more severe. And for the 69 drought events studied, it was 65%. So, of these attribution studies included in this particular study, scientists found that human caused climate change has altered the likelihood or the severity of an extreme weather event in 79% of the cases, and it's made it more severe or more likely in 70%. Extreme heat is definitely on the rise, and it's intensifying, albeit most of us here in North Texas feel like we're coming off of a fairly mild summer for us. However, somewhere, perhaps a lot of somewheres in the world, have or are having one of their hottest seasons on record. And globally, the annual average temperature has been rising since the beginning of the 20th century, and temperatures are expected to continue to rise through the end of this century. And the CDC says temperatures will continue to rise as people add more heat-trapping greenhouse gases to the atmosphere. As a result, scientists expect heat waves to become more common, more severe, and longer lasting. More extreme heat will likely lead to an increase in heat-related illnesses and deaths, says the CDC, especially if people and communities don't take steps to adapt and protect themselves. This is a lot, but here today to help us unpack this and understand this is a very smart group of people that we are just so happy to have. Today we have with us Larry Kalkstein. Larry is a professor and he is a bioclimatologist who specializes in the impact of weather on human health. His research in applied climatology has dealt with problems such as weather's impact on heat-related illnesses and understanding how reflective roofing and paving materials can significantly alter summer heat and health problems, among other issues that he studied. Larry has served as principal investigator for projects dealing with the development of heat and health warning systems for major cities worldwide, as well as the development of numerous weather indices for use in applied climatology research. Larry presently serves as chief heat scientist for the Arch Rockefeller Foundation, developing the first international heat wave ranking system. We want to hear more about that to see if they rank heat waves like they rank hurricanes. Larry received his undergraduate degree from Rutgers University and his master's and PhD from Louisiana State University. Welcome, Larry. We're so glad you could be with us today.
Thank you, Bernice. Thank you for inviting me. I look forward to the discussion.
Great. Our other guest is Jaime Madrigano. Jaime is a policy researcher at the RAND Corporation, and her research focuses on environmental and social determinants of health, including environmental pollution, extreme weather and disasters, and the built environment, with an emphasis on environmental justice. Jaime's particular expertise is in using epidemiologic methods to inform policy. She has worked with local health departments and community-based stakeholders to conduct health and environmental needs assessment and leads a study to assess whether community resilience mitigates the health impacts of natural disasters. Jaime has also conducted research on public health risk perception and how it's communicated. Prior to joining RAND, Jaime completed her postdoctoral fellowship at Columbia University's Earth Institute and was an assistant professor at Rutgers University. Jaime received her doctorate in science in epidemiology and environmental health from the Harvard T.H. Chan School of Health and a master's from Rutgers. And our other esteemed guest is John Nielsen-Gammon, and he has been on the faculty of our own Texas A&M University since 1991. He is currently a Regents Professor of Atmospheric Scientists, and John serves also as the Texas State Climatologist. John graduated from Massachusetts Institute of Technology, receiving a PhD there. And he does research on various types of extreme weather, from droughts to floods, as well as air pollution and computer modeling. As the Texas State Climatologist, John helps the state of Texas make the best possible use of weather and climate information through applied research, outreach, and service on state-level committees. John is also a fellow of the American Meteorological Society. Welcome, John. Thank you so much for helping us out again today. I think you have been with us each of our other 2 years on the air, so we really appreciate you. Thank you so much.
Hey, you're welcome. My pleasure to be here.
I want to start, and it's very briefly before it's going to be time for us to go to break, but I want to start with you, John, by telling us how climatologists define extreme heat and how the climatological definition of extreme heat might differ from how us everyday people define it or think of it.
Well, we tend to think of extreme heat as something really hot. But I suppose someone in the Sahara Desert would regard what we regard as unbearably hot as being perfectly normal. So from a scientific statistical point of view, we often view extremes in terms of things that are very rare. So it'd be pretty unusual for Dallas to reach 110 degrees. That would be very extreme. Whereas Boston, 100 degrees might represent something similarly unusual. So that's, from a meteorological perspective, we think of extremes as being things that are very rare. And that doesn't necessarily line up with the human impact because people have their own physiological responses to heat. And so you can define heat waves differently if you're caring about the human impact specifically.
Indeed. And, John, we're going to go to break, but right after the break, we're going to continue this conversation with you helping us to understand the definition of extreme heat before we go further. So we'll be right back on the other side of the break. We are with Jaime Madrigano with the Rand Corporation, Larry Kalkstein with the Arch and Rockefeller Foundation, and John Nielsen-Gammon, our Texas State climatologist with Texas A&M College. Thank you. We want to give a shout-out now to our sponsors. That is Natural Awakenings, Dallas-Fort Worth Magazine, the Green, Healthy, and Sustainable Living Authority for the DFW Metroplex and North Texas communities. Print issues of Natural Awakenings can be found in all Whole Foods markets, natural grocers, central markets, sunflower shops, and many, many other locations, as well as available free for download online at nadallas.com. Our other sponsor is North Haven Gardens, serving the Metroplex since 1951, the most respected horticultural establishment in North Texas, offering gardening and plant education, concierge services, DIY classes, gifts, and more. Check them out at nhg.com. And our other sponsor is Lynn Dental Care, practicing dentistry for over 38 years with a holistic approach, non-mercury, looking at the whole body. Specializing in periodontics, Dr. Lynn is board certified by the International Academy of Oral Medicine and Toxicology. Check them out at lindentalcare.com. Thank you, sponsors. Welcome back to Healthy Living, Healthy Planet Radio today. To today's show on extreme weather events. Specifically today, we're talking about extreme heat. And right before the break, we were talking with John Nielsen-Gammon from Texas A&M University, our Texas State climatologist. And he was explaining to us, I guess, the nuances in defining extreme heat, especially trying to parse it between what the scientists say and what we experience as everyday folks.
You know, one thing you mentioned, the heat, severity, and frequency both going up. Those go hand in hand when we're talking about extreme temperatures. If we reach higher temperatures, that means higher temperatures are more likely. So it's not like frequency and severity are both going up. They have to both go up because it just gets worse across the board. You
said something interesting there. You say they have to both go up, frequency and severity. Is that at the same time?
Yeah, basically, yeah. If you have more days over 100, then that means that you pass that threshold more frequently and you reach higher temperatures more often at the same time. So you really can't go one way without going the other at the same time.
Indeed. I've seen that, and you made it really clear that extreme heat is regional. Because I am a native Texan, and I thought I had saw heat. And I know generally back in the day we considered a heat wave, I think it was 5 days over 100 degrees. But then I lived in South Florida for 17 years, and I believe there heat wave is considered maybe 5 days over 90 degrees, even though it seemed hotter because they had humidity.
Yeah, the Weather Service itself issues heat advisories and heat warnings based on different criteria in different parts of the country. The same conditions that would cause a heat advisory, heat warning in, say, Chicago, might not even get a heat advisory in Texas. And part of that is, the higher temperatures are more common. Also, both our bodies and our environments are adapted to higher heat. We're more used to the heat. It's been shown that heat waves early in the season actually cause bigger health impacts than heat waves later in the season. And then also, air conditioning is more common. Of course, some people can't afford air conditioning, but those who can definitely have it in Texas, whereas farther north, they may not have it so prevalently.
And so, John, what is the underlying cause of extreme heat?
Well, the sun is blamed for a lot of things. I blame the sun for this also. We have the Gulf of Mexico to our south that gets warm during the summer months. And so that gives us not just the high heat, but the high humidity, which is a big problem also. And if we're going to have a heat wave, typically that'll be a circumstance where we have some hot, dry air higher up in the atmosphere. And with the air higher up, that sort of traps the heat that builds up low down near the ground as well, so that the whole column of the air gets hot. And that can just last for a day or two, or it can potentially last for weeks, depending on the circumstances. And that's when we start to see those record temperatures in Texas.
And what role does climate change play in that?
Climate change might be making the jet stream patterns more stagnant, allowing heat to be locked in longer. But it's definitely causing temperatures to go up everywhere, and it's causing the Gulf of Mexico to be warmer. So that means the humidity is higher at the same time. So it's sort of like the temperatures all across the spectrum from cold to hot are getting hotter, and that makes the heat waves more likely and more intense, just as a matter of course.
And one other thing before I go on to Larry and ask him something, and that is the greenhouse gas effect. How is it impacting heat?
Well,
because it's my understanding that the greenhouse gases tend to trap and treat us down here on planet Earth like we're in a greenhouse, trapping that heat in as well.
Yeah, that's what's driving the increase in temperatures globally. Also, I suppose we should mention that humans are affecting temperatures locally as well. For example, heat waves decreased from the early part of the 20th century, the latter part in Texas, probably due to increased irrigation for cropland, increased reservoir development. Mm-hmm. And now we're seeing with increased urbanization, temperatures going up, especially hot in urban areas where you've got less ground, less evaporation take place, and more built environment to trap the heat also.
Is this where you commonly hear the term heat island?
That's right, yeah. Urban heat islands are warmer both during the day and at night. Both of those can have big health consequences.
What is an urban heat island?
Originally, the term was devised to represent the whole city being hotter in urban areas than rural areas. But since then, we've been mapping out urban heat islands at a much finer scale. We find that places that are more industrial or have fewer trees and fewer parks tend to be the hottest parts of the city. And those are the places then that become most vulnerable, because those also tend to be places, with less affluent communities where there's less air conditioning as well. So those factors just compound on top of each other to increase the heat risk.
Indeed. Thank you, John. Larry, I want to ask you, does extreme heat have an effect on other weather events, like storms and droughts and tornadoes and flooding and what have you?
For sure, extreme heat has an effect on both floods and droughts, storms, floods, and droughts, all of them. You have to remember there isn't just one kind of heat wave. We deal with air masses or huge umbrellas of air that float across the country. Some are very hot and very dry. They come from desert areas like the Sonoran Desert in Phoenix. Those heat waves are very different than the hot, humid air masses that John was just discussing that come from the Gulf of Mexico. And they can have different effects on other weather events. So obviously, if you get these dry, tropical air masses coming in from the desert, clearly droughts are going to be exacerbated. And as it gets hotter, the evaporation rate or need to evaporate is going to go up. If there's not enough water around, it's going to be a drought. On the other hand, the hot, humid air masses from the Gulf of Mexico can also become more extreme, and the more hot and humid air masses can increase flooding. So this is an interesting dichotomy where you can have more droughts during some heat waves and more floods during other heat events.
Oh, my, that is interesting. I want to ask you, which would you say is the most common or most direct result of extreme heat? But I suspect
it depends where you are. I mean, if you live, I live in Southwest Florida, right on the Gulf of Mexico, and John might be interested to know that I have a weather station for 19 years. It's never gone over 93 degrees where I live, and here I am in Florida. Now it stays warm very long, and it doesn't get cool overnight. But that's a very interesting fact. It's been hotter in Caribou, Maine than it has been in my house. And the other thing I just want to bring up, which is related to this, is that it's not just the heat that has the major impact. It's the variability of climate. I want to introduce this in the conversation because it's hot here all the time in South Florida. We have very few heat-related deaths down here. People are adapted, as John had discussed. We are all adapted, know how to live. Everyone's got air conditioning. We're used to everyday heat. It's places like Kansas City or Chicago or Philadelphia where it's usually in the 70s or 80s in the summer, and then you get a 100-degree heat wave. High variability where people start to react in a negative fashion. So with climate change, variability, we're not so sure what's going to happen to variability. Is the weather going to become more variable? Is Philadelphia's climate going to look like my climate in 20 or 30 years? The variability part of the climate change models is weak, and that's going to be the determinant as to how many people are going to die from the heat in the future, whether we keep the variability or it becomes less variable.
Indeed, but I have to tell you, I lived in South Florida, in Miami, for 17 years, and when I first moved to South Florida, I thought that heat was going to kill me, and it was the humidity. I moved there from right here in North Texas, and when I moved back 10 years ago, I would tell all my friends, oh, I love the heat as long as it's dry. And then, John, in these last 10 years, it's gotten humid on me here. And now it's almost just as humid as it was in South Florida. And that's when I noted that they would say we were having a heat wave. I think it was over 5 days over 90 degrees. They declared a heat wave. So it's interesting indeed. Let me ask you one other thing, and then I want to move on to Jaime to talk about some health aspects. Larry, I mentioned in my intro something that I read, and of course it says all types of extreme weather events should not be blamed on climate change. So which types of extreme weather events should we not be blaming on climate change?
Wow, how about freezing? In terms of heat, remember that climate change comes in three different formats. There's the urban heat island, where the urban areas are becoming hotter, and we know the climate is changing, but what we don't know is the proportion that's changing either to urban areas increasing, natural causes, or greenhouse gas-induced changes. And I think it's very difficult to get a handle on what is the proportion, a third, 90%, 5%, and 5%. I don't think any scientist can give you a precise answer on that. So part of the problem here in determining what's going to happen in the future, which ones are going to be less extreme, is knowing what the proportion of increased heat is due to. Everyone knows the Earth is warming. I think it's more of a question as to what is the proportion of the three chief proponents: climate change caused by humans, the trace gases, the urban heat island, or just natural variability. I know that didn't answer your question perfectly.
No, I kind of suspected that it would be something like that when I ask it. And what comes to my mind, or what I've read to be cautioned about, is that there is just going to be some natural variability.
We don't know what the proportion is, and I really don't think anyone can pinpoint it precisely. Clearly, the urban heat island is very important. Urban areas are getting hotter faster than rural areas are. So we know that a portion is due to the urban heat island, but rural areas are also getting warmer. That's probably due to more of the human-induced trace gases in the atmosphere. But I will never even venture a guess as to the proportionality of that.
I understand, indeed. And we're going to go to break now. And right after the break, we're going to come back to Jaime so she can talk to us a little bit about the public health impacts of extreme heat. Thank you all. We'll be right back on the other side of the break with John Nielsen-Gammon from Texas A&M and our Texas State climatologist, with Larry Kalkstein from the Arch Rockefeller Foundation in South Florida and Jaime Madrigano from the RAND Corporation. Thank you all so much. Welcome back to Healthy Living, Healthy Planet Radio, to today's show on extreme weather events, our first title or show topic on extreme heat. And I want to move now to look at some of the public health impacts. And so I want to talk with you, Jaime. Climate change is expected to increase, as we've talked about, frequency, duration, and intensity of heat waves. Talk to us a minute about how is extreme heat threatening our public health and what are the major health impacts?
Sure. Thanks, Bernice. It's great to be here. And we know that there are a lot of public health impacts of extreme heat. I think people tend to think of the most obvious things like heat exhaustion or heat stroke, which can be fatal. And that's, when the body just, can't cool itself down. But we know that there are a lot more kind of broader impacts to the general public and to vulnerable populations when we have an extreme heat event, as John and Larry were both discussing. And these types of things sometimes are not known right away because, again, they might be considered an increase in heart attacks that occur or an increase in respiratory hospitalizations associated with respiratory diseases. But when we look at the data of all of those types of hospitalizations or even deaths that occur during a heat wave event, we can clearly see that there are patterns. And we do this by looking at the hospitalizations or deaths that occur during an extreme heat wave event, as John and Larry were both talking about, how we define those, and comparing that to the same time of the year for the same location from many other years. And we can clearly see excess hospitalizations or deaths for a whole variety of types of causes like cardiovascular disease, respiratory disease. Even there is some evidence that extreme heat events can be associated with poor reproductive outcomes and a wide variety of other things.
Indeed. And over the course of the 2 years of the show, it always comes up, of course, as you just mentioned, that many times our numbers may perhaps be underreported or underrecorded because of how we have to tell many things on an anecdotal basis. We're seeing some of the same thing with COVID. The heat wave lightning rod didn't come and strike them, but you had a lot more deaths after this occurred. And so I know that's problematic. But I ask all of you all as scientists and researchers, are we moving the ball forward any in terms of that whole area of things that will help us better in terms of being able to, I guess, more directly or more quickly make the attribution?
Well, I think the awareness of heat-related problems has been increasing over the years. One of the things that we do in our shop is to develop these heat watch warning systems and now categorizing heat waves, which you mentioned earlier in the show. And this also involves not just the Weather Service calling an excessive heat warning, but the way the cities respond. Just calling it on the radio won't do much good. The city better open those air-conditioned shelters and better help the poor out and deal with the homeless and go door to door as they do in some cases. So one thing that has happened and that we're seeing is that we are not seeing an increase in heat-related deaths at the very least. Even though the weather is warming, there is a basic steadiness in that. And in some places, we've actually seen declines where cities have developed very good intervention plans to deal with heat. So there is a little bit of good news here because since heat is invisible, it's not like a hurricane or tornado where you rip an area up. The place looks exactly the same before and after a heat wave, even if 1,000 people died. Where people are becoming aware of it and heat is becoming more visible, at least in the minds of the general population, which is a good thing.
Indeed, because I know it makes me much more tired. And Jaime, you were going to say?
Yeah, I was just going to add that in some places, too, for example, I've done some work with the New York City Department of Health and Mental Hygiene on heat, and they are actually using syndromic surveillance to look at heat events. So again, to be able to try to capture a little more quickly than the typical a year later assess all of the data, but to be able to kind of understand those fluctuations when a heat wave occurs and the impacts to public health a little bit more in real time.
Indeed. John, let me ask you, in your recent peer review report that was backed by Texas 2036, you stated that the number of 100-degree days could double by the year 2036. Can you tell us a little bit about the key data points that brought you to that conclusion, and how will life be then?
Well, they've already doubled compared to the middle of the 20th century. We looked at stations all around the state of Texas and grouped them into categories. Coastal stations were one category, for example. And, the thing about Texas summers is temperatures will get up to the mid-90s and the upper 90s and stay there for a long time. So if you just add a few degrees to that, suddenly temperatures are staying in the 100-degree range. And somehow or another, 100 degrees doesn't just sound worse. It really feels worse. You can tell the difference if you've got a 100-degree day. So yeah, compared to like the first couple of decades of the 21st century, we expect that by 2036 or so, a typical year will have nearly double the number of 100-degree days in it, no matter what part of the state you're in.
So do you think there's a solution, economically or otherwise, that could slow down or mitigate the upward rise in temperature each year? What do you think?
Well, I mean, the long-term view, we got people worrying about this in Glasgow with COP26, the climate change talks. Anything we do to reduce greenhouse gas and methane emissions and so forth will have effects 10 or 20 years down the line. The biggest impacts will be much later as we transition to a whole different set of energy sources. But on the short range, all of the existing solutions are local solutions, such as cities taking better care of the residents, having heat relief stations in place if there's going to be a heat wave, having more green space available to reduce the urban heat island. Green roofs have been proposed, so that sort of thing also, but I'm not sure if people live on roofs that much, so it doesn't make that much difference to me.
But what about planting more trees?
Yeah, the trees are great for a couple of reasons. They pump water out of the ground and evaporate it, so they serve as gigantic swamp coolers. Plus, they're blocking sunlight so that the people who actually are out and about can be in the shade rather than in the direct sun. And that difference between shade versus sun is equivalent to 10 degrees or more of temperature.
May I amplify on that for a second?
Please do.
There are products that are now available that can cool urban areas, not the whole world or the country, by up to 2 or 3 degrees. And we're working with these right now. The 3M Corporation and other large corporations make reflective materials that you could have put in the shingles of roofs that quadruple the reflectivity of solar radiation on the roof. So the average roof reflects about 7 or 8% of the solar radiation. The new roofs reflect 30%. So what you're getting is less energy coming into the home, which means less air conditioning, which produces heat in itself. You've been by those big compressors. And also you're taking energy and putting it back out into space. So the 3M Corporation has funded a bunch of us to evaluate if half the roofs in an urban area had these materials, how much cooler could cities be? And as I said, this is a couple of degrees, and you may say, well, if it goes from 100 to 98, that's not such a big deal. But I have news for you. There is a threshold where people get sick and die, and that couple of degrees could be below the threshold for some people. And we have found through our modeling a 25 to 30% reduction in heat-related mortality. Trees also help, but they do add humidity because of the process that John just stated. But I just wanted to bring one last product up. 3M has developed a pollution-absorbing granule to put into shingles. And these granules absorb nitrous oxides, and then when it rains, the nitrous oxides run off the roofs and fertilize your lawn. I think this is one of the most ingenious things I've ever heard. But we are now working in San Antonio, I might tell you, of all places in Texas, with the San Antonio air quality people to determine if the widespread use of this material will actually lessen pollution, which is an ancillary health disadvantage when you have a heat wave. Sorry to say it so simply, but
yeah.
this is important stuff.
You said it reflects the heat. But again, from what I understand, say it's reflecting it above the house, but the greenhouse gases are still kind of causing it and trapping it all down here.
Well, not 100% of it.
Right.
And so what you want to get is if you can reflect more heat, I don't care how many greenhouse gases you have up there, that's going to be a benefit because some of it is going to escape. And
Indeed.
You may be right that some proportion might come back down to earth. But trust me, Bernice, when you say you'd rather have it going that way upward than
down on us, for sure. Right. Oh, indeed.
And let me add to that. If the energy is going up in the form of the reflected sunlight, the greenhouse gases can't trap it. It's going to go straight through the atmosphere, just like it got through the atmosphere to make it to the roof in the first place.
Oh, good. That's why I'm so excited to talk to you, all of you scientists and researchers. You just make me much smarter, and I hope you're making our listeners much smarter, too. Thank you all so much. We're going to go to break right now, and we will be back on the other side of the break with these very smart people who will help to make us much smarter. Thank you all. We want to give a shout out now to our sponsors. That is Natural Awakenings, Dallas-Fort Worth Magazine, the Green, Healthy, and Sustainable Living Authority for the DFW Metroplex and North Texas communities. Print issues of Natural Awakenings can be found in all Whole Foods markets, natural grocers, Central Market, Sunflower Shops, and many, many other locations, as well as available free for download online at nadallas.com. Check them out. Our other sponsor is North Haven Gardens, serving the Metroplex since 1951, the most respected horticultural establishment in North Texas, offering gardening and plant education, concierge services, DIY classes, gifts, and more. Check them out at nhg.com. And our other sponsors, Lynn Dental Care, practicing dentistry for over 38 years with a holistic approach, none mercury, looking at the whole body. Specializing in periodontics, Dr. Lynn is board certified by the International Academy of Oral Medicine and Toxicology. Check them out at lindentalcare.com. Thank you, sponsor. Welcome back to Healthy Living, Healthy Planet Radio, to today's show on extreme weather events. Specifically, we are talking about extreme heat. And we are here with John Nielsen-Gammon from Texas A&M University and the Texas State climatologist, Larry Kalkstein from Arsh Rockefeller Foundation in Southwest Florida, and Jaime Madrigano from the RAND Corporation. Again, thank you all so much for being with us today. I want to go to Jaime right now. And Jaime, has there been any perhaps minor or seemingly unnoticeable changes to how citizens or everyday people have adjusted to extreme heat over the years? Are you seeing any adaptation or evolution?
Yeah, well, we have seen that in the U.S. there have been studies that have looked over sort of several decades of heat-related mortality. And we have seen that the rise of air conditioning prevalence has contributed to mitigating those heat mortality relationships. So certainly, I think we know that air conditioning is one of the most adaptive mechanisms that the population has used to mitigate the health consequences of extreme heat. And there are, as we've talked about, there are a number of other things right now that are being looked at in terms of a sort of at the policy or community level, such as the things like cool roofs or the natural landscapes and tree plantings. And we're, as Larry was mentioning, just kind of looking at evaluations of those things right now, more at the sort of community level type of evaluation.
And one that I use, that I like, that we use a lot here in North Texas, are the misting machines. In the summer, on the outdoor eating scenes, they're there. And I actually know a couple of people, as a part of their landscaping business, they install them in people's homes. So they're getting quite popular, the misting machines.
And I know those were on the rise as well particularly during last year, during the COVID pandemic, because some of the interventions that we also use tend to bring people together. So bringing people who maybe can't afford air conditioning at home to a common cooling center. But since that was made more difficult due to the need to distance from each other with COVID, there was a lot more increase in many locations of other types of ways to mitigate heat, such as misters and things that could be kind of cropped up.
And Jaime, you mentioned earlier that cities like New York are particularly heat sensitive. What makes a city heat sensitive, and what perhaps are some other heat sensitive cities?
Yeah, I think, there are heat sensitive cities all over, as we've discussed. When the work I've done in New York actually looked at within New York City, where are the most heat sensitive areas? And so I think it is true that certain northern latitude cities have had less adaptation to heat over the years. So let's not say New York, but let's say the Pacific Northwest. We saw the lower prevalence of air conditioning just this past summer, and how that might sort of affect at a population level greater impacts toward heat. But we can think about this as well as within a city. And we looked at this in New York City, whereas, again, because of some of the things that were already mentioned by John and Larry, we have these major temperature differentials within a city due to blacktop and asphalt being concentrated in certain areas with less tree cover. Those areas of the city can retain a lot more heat. And as well, those interact with different types of population factors where populations maybe have less adaptive capacity because either they can't afford air conditioning, there are competing types of bills, and so they can't run their air conditioning all of the time. And so these could make particular areas of cities much more vulnerable than other more affluent areas.
But as I think about New York City, it's very densely populated, but they've got so many tall buildings. Some places, there's a lot of shade in a lot of places. Is that affecting heat or not, the shade?
Yeah, that certainly does. And we, in terms of where we saw the greatest heat sensitivity when we looked at the mortality data in New York, was actually in places where there are some of those not in the center of Manhattan. Right. It was in some of the other boroughs, particularly in the Bronx, central parts of Brooklyn, and also in Upper Manhattan in the Harlem area. Of course, there are a concentration of factors that go along with less tall buildings, including socioeconomics and other types of factors that contribute to that vulnerability.
And Larry, I want to start with you on this. What has been the impact, if any, of extreme heat on our plant and animal life?
Yeah, well, there certainly have been shifts. The most important shifts are in agricultural crops, which is quite worrisome because, again, if you are going to have more droughts, and if a place is not a very moist place to begin with, this is going to shift agricultural belts to the poles further north. And this has been a problem and has been a threat for a long time that the Corn Belt would be shifted too far to the north to really be it would leave the U.S. and places in the southern edges where they grow corn would no longer be able to do it. Now, luckily, rather than be a fear monger, I want to tell you that scientists have come up with drought-resistant hybrids of these crops just to prevent that kind of thing from happening. And these are people that know much more about this than I do. But in fact, it is not as if agricultural yield has gone down. The other thing that happens is that the phenology of plants change when they bloom, when they lose their leaves, when things flower. And if you make the growing season longer, there are some advantages to that, clearly. But on the other hand, there are some plants that need short growing seasons and are adapted to them. So there are impacts on plants. And of course, the ones on animals are rather obvious. If a certain weed is starting to invade weed because it's too dry for another kind of a plant, and that weed is not palatable to a certain animal, that animal is going to become extinct from that particular area. And there are some cases, even in West Texas, where some of this is happening, that along with bad land use practices, where cattle and other things have downtrodden the soil and it doesn't hold as much moisture. There's mesquite growing everywhere where it didn't used to grow, and be assured that has moved a lot of animals around. But I don't want to blame that strictly on climate change. There's land use mismanagement as well that has occurred among people. So.
Indeed. Larry, let me ask you this. An article that I saw recently in the Washington Post highlights where Seville, Spain, has a new system of ranking and naming heat waves, which they're going to implement in 2022. Can you talk to us about this, as well as about the heat warning systems that you've developed in a number of cities? Oh,
I'm so glad you asked this question, and the Rockefeller Foundation is going to be glad as well. Yes, there is now a movement afoot to rank and name heat waves, and we now have 6 pilot cities that we're working with. Just today at the COPS conference, there was a big, my project officer at Rockefeller led a session with the mayor of Athens, Greece, and of Seville. Both cities are going to be using our new ranking methodology. And what we're going to do is rank heat waves similarly to the way they rank hurricanes, except we're probably going to have 3 categories. Some of our research is, it seems to be there are 3 modes to heat waves. That's number 1. Number 2, it's going to be based on health outcome, not on meteorology.
I like that.
So what we're going to be doing is using our modeling, we can estimate how many people are going to get sick and die during heat waves. And as someone mentioned earlier, early season heat waves kill more people than the exact same heat wave intensity late in the season. Why? People aren't adapted. Also, there are more susceptibles around to die early in the season. Then when if they happen to be killed off, there are less to die later on. We don't think those 2 heat waves should be ranked the same way, because the human health impact is worse in the first heat wave. So the first heat wave may be a category 3, and the exact same meteorological event at the end of the summer would be a category 1. And this, of course, is all being done so that interventions can be improved, because all we do today is call an excessive heat warning. We don't say what the category is. It's just an excessive heat warning. And it would be much better for stakeholders if they knew it was a 1, 2, or 3. If a Category 1 hurricane is hitting Marco Island, Florida, where I live, my wife and I stay put. Be assured when a Category 3 comes, we're leaving Dodge immediately. So it's very, very different. And we're hoping this is going to be helpful. And I don't want to go on too long, but our heat health warning systems are also based on human health outcomes. So we think this is the way meteorological warnings should go in terms of heat. The health outcome, and I think that the work Jaime is into is very important to this kind of stuff as well.
I can see just listening to you that Jaime, with her policy work, is going to be pulling a lot on there. So if you all didn't know each other before, now you do. So that's good. We have 1 minute before we go. Jaime, last word. What do you think ordinary people in their everyday lives can do to help drive solution?
Well, I think this was mentioned earlier. Awareness is becoming more prevalent as we just discussed the health impacts of heat, and I think that's primarily one of the most important things. People have a role to play themselves. They can be thinking about their behaviors during heat waves, how to potentially modify them, how to make sure they're drinking enough, trying to stay cool whenever possible. But then we also have a role to play with our representatives and in our local officials to think about what are the solutions, some of the innovative things that Larry was mentioning, that we were talking about earlier, and some of the more common things like street trees and where they should be directed most, because there are people dying every year already from heat, and I think that's going to get worse.
Indeed. Thank you so much. We really appreciate you all helping us out. You've made us much smarter. We have been with John Nielsen-Gammon from Texas A&M, the Texas State climatologist, Larry Kalkstein from the Rockefeller Foundation in Southwest Florida, and Jaime Madrigano from the RAND Corporation. Thank you all so much. We really appreciate you helping us out on this. And thank you, listeners, for listening in today to Healthy Living, Healthy Planet Radio. The conversation starts here, but our goal is for it to continue in your home, in your social circles, your workplace, at the water cooler, and in the grocery checkout line, so that we can all work together to realize that healthy living is simply not possible without a healthy planet. Our culture is a result of 1 trillion tiny acts taken by billions of people every day, like yourselves. And each of those tiny acts can seem insignificant, but all of them add up, one way or the other, to the change we each live through. This is your host, Bernice Butler. Thank you for listening, and join us again next week as we continue our November conversation on extreme weather events. Thank you.